Good morning, everybody. Welcome to the live stream this week. Sorry for the bit of a delay. Got a little caught up in the office this morning with some questions that had come in from some other folks. But we got started pretty close to on time, so I guess that's good enough. We do what we can around here. We'll be talking about installing and managing end-user technology, but before we get into that, let's talk about some announcements. So one of the first things, I guess, to talk about is the fact that we're getting pretty close to the end here. You know, we only have about 3 weeks or so left in the course. We're getting really, really close to the end. And as a result, you know, it's coming up really quickly on the end. And I know when it comes up really quickly on the end of the semester, that's when everything starts to come due in all of the courses, and all your final projects and your final exams come up, and we have final projects and final exams in this course. So this is just a quick reminder that your final project is coming up due. If you haven't been working on that, you probably should be. You know, you knew about that final project on the first day of the semester, way back in, when was it? Was it early September, late August? Seems like forever ago now. But we'll be quickly reaching the end of the semester here in just a few weeks. And we've got the Thanksgiving holiday next week. So you'll want to be working on these things so you don't have quite as much to do when it comes crunch time around December 11th. I've also graded all of your assignments from the previous module. So you'll want to check out those grades and make sure to check out the comments on those assignments, as always. You know, if you have any questions about any of that stuff, please feel free to let me know. But we are talking about installing and managing end-user technology this week. And this week's live stream's kind of piggybacking off of last week's module. You know, last week we were talking about the end-user needs assessment. And so once you determine what your end-user needs, then the next step, of course, is that you have to install and manage those items. So it only makes sense that we do installing and managing end-user technology after the end-user needs assessment. So let's talk about some of our topics within installing and managing end-user technology this week. And start off with a system installation overview. So when we are approaching installing new systems, whatever they may be, whether they're desktops or servers or whatever we're looking at installing in an organization, we have this list of different considerations that we need to make as we approach this installation. And one of the biggest things that we can do is we have to consider the pre-installation site preparation. So before we move in anything, before we move in the very first piece of equipment, we have to consider the site where we are going to move the equipment to. This is probably one of the more critical elements in installing and maintaining this equipment, is having a proper site ready for it. We'll also talk about site management documentation, which is what you have, I believe, for your lab this week as an example of site management documentation. The actual hardware installation itself, operating system and network installation, application and software installation, and then installation wrap-up tasks. So we start out with pre-installation site preparation. And as we said, this is probably the most important task on our list, is trying to make sure that our site is ready for us. And we have this checklist of issues here that we need to consider before we move in any piece of hardware. Before we move in the very first piece of hardware, we need to make sure that these issues are considered. Space requirements, space constraints, special furniture, material storage requirements, ergonomic issues, ADA and OSHA accommodations or issues, adequate power supply, power conditioning requirements, wired and wireless network access, air conditioning, lighting problems, and fire suppression system. Making sure you have that and you have it operational. The first thing that you have on the list here is that you have the space that you need. What are the space requirements for whatever piece of hardware that you're bringing in to this area? What is the footprint for this device? If it's a server, for example, a server is going to have a very large footprint. If it's a desktop, it's going to have a much smaller footprint, but it's going to take up space in somebody's office. So you have to consider the space requirements for these devices. So what are the space requirements? What is the area that this item needs? And that couples with space constraints. Now you might be thinking, aren't space requirements and space constraints pretty much the same thing? And kind of, but not quite. Because really we can look at space requirements in terms of square footage, right? Like we can take the measurements of a room and we can say, okay, this room has, 800 square feet of space where we can put stuff. But when we look at space constraints, that's where things can change. That's where that footprint becomes even more critical, because we start to think of things like, well, we've got 800 square feet of space, but how does this footprint fit on the actual floor plan? What if there's a bit of plenum sticking out in my way? What if there's, some kind of load-bearing pillar where I'd like to put this server? What if I have technically 600 square feet of space in a room, but the floor is uneven? So in order to have my server on level ground, I have to have it on only half the room. So that constrains me to 300 square feet of space. And maybe that 300 square feet of space is in a strange orientation. We have to kind of think of these things in terms of the room itself, because it's really easy for us to kind of say, okay, what's the footprint of this device? Okay, it's 6 foot by 3 foot, 18 square feet. We've got a huge room here, 600 square feet of space. It's easily going to fit. And while that checks off the box of space requirements, it doesn't necessarily check off the box of space constraints. Because with space constraints, we actually have to think about the physical space. We have to think about the other stuff that's in the room. We have to think about the way that the room's physically laid out. We have to think about any load-bearing pillars that divide up the room, uneven floors that divide up the room, other items that are in the room, that sort of thing. Special furniture. If I have to install some servers, I'm also probably going to need a server rack. If I need to put desktops in a space, I probably also needed some desks to put them on. It's not enough just to think about the devices that we need to put in a space. We also have to think about what we have to put these devices on as we put them in a space. Or in as we put them in a space. So, I mean, let's consider for a minute, you're a help desk agent, and you're tasked with putting together a new computer lab, brand new computer lab. We need you to source everything for this computer lab. And you're like, okay, we need computers, we need monitors, we need keyboards, we need mice. Easy. Well, you also need desks, and you need chairs. Because you're not just going to have people come in and use the computers on the floor. Right? We have these furniture requirements that go along with these device requirements. Oftentimes, we kind of think about our devices in kind of a vacuum because that's what we're in charge of, but it's more than that. Material storage requirements. If we have stuff that we need to store, especially if it's specialized equipment, especially if there's special safety and health regulations around said equipment, we need to make sure that we have it stored in the proper containers and in the proper storage units. Like there are specialized fire-safe cabinets for specific elements, for specific storage pieces. Ergonomic issues, and we've kind of discussed ergonomics before when we discussed workplace setup. When we discussed that, when you're thinking about the special furniture and you're thinking about setting up a space, we go back to that computer lab. You also, in addition to the devices and the furniture, when you go in there to actually set it up, you have to think about the ergonomic concerns of the users that are coming in there to use that computer lab. ADA and OSHA accommodations are issues. So you're not just thinking about the devices that are going in the space and the furniture that are going in the space, but you're thinking about the people that are going in the space, and that couples with that ergonomic issues there as well. We're thinking about the people that are coming into this space to use this space. For example, we want to make sure that we have enough room between devices for a wheelchair to fit through. That's part of our ADA, or Americans with Disabilities Act compliance or accommodations. Having adequate power supply. If you're going to go create a computer lab and you choose a room that has only one set of outlets, you're going to have a hard time. You want to be able to provide adequate power to the devices that you're trying to utilize. You want to be able to actually run the things that you want to run. And along with the power, you want to be able to condition that power properly. We're kind of oscillating back and forth. Speaking of power conditioning, oscillation. We're kind of going back and forth between data center type situations and end user type situations. And with power conditioning requirements, they could really happen for either. In data center sort of environments, you see oftentimes the need for three-phase power. You see the need for UPS systems, large uninterrupted power supplies. But even in a smaller environment, you might need those small uninterrupted power supplies to help condition the power for a user so they don't experience power surges on a line. It reminds me of an issue that I had here at the college several years ago. Back when they still had high school proms out in the gym. Several years ago, my office was on the walking track above the gym here at the college. And I was in there just working away one day, and all of a sudden, there's just this power surge. And my computer just fries out. I walk out the door to see an individual who was getting ready for one of the high school proms out there, plugging two giant, 500 or 1,000 watt lights into the outlet that's right outside of my office door that was presumably on the same circuit. That my desktop was on. And of course, there was no power conditioning there. So that sudden draw on the circuit just caused some issues. So that's something that we have to consider. That's something that we have to think about this power conditioning. Network access. Having access to wired networks where you need access to wired networks, making sure people have access to the wireless everywhere where they go on campus, or wherever you're working at where you have a wireless setup. You can kind of think about that in relation to the campus, right? Like if you're on campus and there's a huge wireless dead zone where a lot of students go, that's a failing. We need to put a hotspot there. We need to put an AP there. Air conditioning and environmental control for equipment so it doesn't, so we don't have overheating or humidity or those sorts of issues with devices. Lighting problems so that you can see. And fire suppression systems, just in case the worst happens. You want to be prepared for that. And so this is all before we even take the first bit of hardware into a place. We want to make sure that we have all of these things wherever we want to take something. We want to make sure we have all of these items checked off of our checklist. So how do we locate technology components? Well, in locating a computer system, one of the things that we want to do is we want to devise strategies to conserve space. Space is a finite resource. Right? At every organization, there is only a limited amount of space available. So you want to maximize that space. Everything has that footprint that we were talking about earlier, and it's that length times width. It's that amount that it takes up on the tabletop or on the floor of whatever kind of device it is. In this instance here, we're talking about, the square inch measurement of a desktop PC, but we could be talking about the square footage of a server rack or whatever. Of whatever system unit or device that we're utilizing. Now, we have some good measurements here for ergonomics, and these are things that you might want to write down. Now, these could vary slightly by user, as people vary. But in general, when it comes to keyboard and mouse, our optimal height is 26 to 28 inches from the floor. So when somebody's comfortably seated, roughly 2.5 feet from the floor, we see the keyboard and mouse. Our display screen is an optimal user view of straight ahead or slightly down based on the user's point of view. Worst case scenario is having somebody craning their neck, looking upward. These are all ergonomic things. Like the keyboard and mouse thing is trying to create that perfect ergonomic angle based on how you're sitting with your arms resting on the table. Ideally what we're going for is this sort of kind of kind of 90-degree angle with a slight wrist bend when we're sitting at a comfortable height. So we get that sort of comfort in that sort of way. So we're supported by our armrests. And we have this sort of structure here. A straight line between the armrest and the top of the desk. No variance there, so it makes it all wonky, right? And convenient access to the printer for loading paper, retrieving printouts, and clearing jams. So you want, ideally, 360 access or at least 270 access. If nothing needs to go in the back of the printer ever, or if there's no jams that need to be cleared from the back of the printer, then you're good there. You want to make sure that everybody has access to all the supplies that they need. Just convenient, quick, easy. And of course, we have this here as a tip, but avoid storing paper in a damp area. There's nothing worse than damp paper. That just sounds gross. I wouldn't want to deal with damp paper, and I don't think you would either. And then there's furniture considerations. The importance of an adjustable chair. A nice chair is exceptionally important whenever you're in any kind of office scenario like this, where you're doing this sort of knowledge work. You want to have the adjustable seat height, the adjustable seat swivel. You want to have as much adjustability as possible because there's no such thing as a standard human being. We're all different heights, all different body types, all different everything. We can try to average things out as much as we'd like, but it doesn't really work out very well. So we want to kind of have as much adjustability as possible with our chairs. A waterfall seat edge, meaning a nice rounded edge. A 5-leg base. And a carpet protector, just for ease of roll. Especially when you get into these types of office situations, like here at the college, I purchased my own chair and brought it in. Because when you think about these sorts of situations, like you're in this chair between 4 to 8 hours a day. That's a long time to be sitting. That's way too long to be sitting. Right. But you got to be sitting in order to do the work, because it's all isolated at this desk, at this computer. And so again, like, we can't think about these devices as they're in a vacuum. We also have to think about the furniture that goes along with them. So when we are doing device setups, we're not only thinking about the devices, but we are thinking about the furniture and things of that nature that are going along with them. Now, we won't always have the input on the furniture that goes along with the devices that we install. However, it is important to know this stuff in the event that we are or have been given the opportunity to consider these issues. I don't want to take forever with this live stream, but we do have a ton to talk about. So I'm going to skip around and find some stuff here. And skip to... let's skip to site management responsibilities. Because I think by now, the majority of you have probably gotten your fill of standard user equipment setup, right? Like, you've got your general hardware, software classes out of the way. Like, you've done basic repairs, you've done basic operating system installs, you've done initial computer setups. We've talked in the past before about, ensuring quality ergonomics and things of that nature. Those are all important. You'll read more about those in your text, but I'd like to talk a few minutes about these site management responsibilities, because that takes us to the next level. Because after everything's installed, after everything's in, it's not over, right? Like, you have to keep managing everything and keep running everything. So you can't just install equipment and then wipe your hands and say, oh, great, I'm done. This is over. I don't have to worry about anything from now on. I mean, that's really when the real work begins, and that's when this site management stuff starts. And it's going to be your responsibility to take on a lot of these issues. And now what you take on out of these site management responsibilities is probably going to vary based on organization. But you're probably going to have to take on several, if not all of these, as a support agent. One is media backup. Making backups of hard drives, making backups of servers, ensuring that backups exist just in case something goes down. As you talked about in other courses that you have, one of the keys to data center management and other site management is redundancy. I want to have backups, and I want to have backups of my backups. Right? So I want to ensure that I have all of my media backed up, just in case of some kind of failure or disaster, that I can easily move into the backup and have nothing to worry about. Monitoring potential security threats. This is something that is a constant practice. You talk about this a lot. disaster and contingency planning, having a disaster plan is probably one of the more important things that you will ever create. What happens when things go wrong? That's the big question. Whether it's a natural disaster, whether it's a fire, whether it's a failure, a power outage. What happens when something that you didn't intend to happen happens? And you have to have these plans, and you have to review these plans, and you have to update these plans on occasion. Then there's preventative maintenance, just going around every once in a while, just making sure everything is looking good. Cleaning. Right? The importance of keeping our data centers dust-free. The more particulate we have flying around, the more potential that it has for getting into the devices and wreaking havoc and causing trouble. Keeping supplies up to date, and then just recycling outmoded devices. So when it comes to media backup, we know that we want to keep files and folders of software and data from PCs and servers on a separate storage medium. We not only want to keep it on a separate storage medium, we might even want to keep it in a separate location. This is going to preserve the data in case the original is damaged or accidentally deleted. Especially in the case of, critical data. We might even want to keep that in an off-site location. Back that up and keep it in an off-site location. Because then if we experience some kind of disaster, if there's a fire or some kind of major issue, then not only could it impact the primary data, but if the backup is on site, it could also impact the backup. But if the backup is off-site or in the cloud, then we have a little less to worry about. When we're talking about security problems and challenges, there are several different sources of these threats, and you've probably talked about these in several of your security classes. We have electronic threats, we have physical threats, and we have internal threats. So electronic threats arise, these are your breaches. It's a breach of information or a breach of resources. A breach that causes some kind of physical system to go down. Physical threat being some kind of damage or disruption to equipment. So if somebody goes out and takes an axe to some of your equipment, that's a physical threat. And then internal threats are from inside the organization, an inside job, people stealing data from the inside, sending it out. Or doing things from the inside. We also have external threats that are from outside. So our internal threats could be electronic or physical, and our external threats could be electronic or physical. Just based on what we have going on. Disaster planning, there are all sorts of types of disasters. Power outages, floods, fires, storms, earthquakes, sabotage. From this, we can talk about risk management. Risk management are the tools and strategies to reduce the threat to an organization from unpredictable, uncontrollable disasters, intentional events, and accidents. And this helps an organization recover with minimal financial or customer service loss. Now, one of the big things here, right, is that if you don't have a risk management strategy in place, if you don't have a disaster plan, and something happens, the majority of businesses that do not have this in place do not recover. Because we're talking about recovering with minimal financial or customer service loss. There's going to be some kind of financial or customer service loss. There's going to be some kind of loss regardless of the situation. But your plan is going to help you get out of it relatively easily. Without a plan, the likelihood skyrockets that you're going to go out of business. So you need to make sure that you have a plan, and we have some tools to help us develop this plan. One of the things that we might want to get is business interruption insurance. We have insurance that actually helps us if a disaster occurs and we have to stop running our business. This offsets the cost to return to normal operation. Engineering inspection identifies the potential for damage to equipment and facilities. So if some kind of natural disaster or physical threat has occurred, what is the impact of that disaster or threat? How has that impacted us? And what is the potential for that to cause greater harm? So we need to have an engineering inspection come in and look at that to see what needs to be fixed right away and whether and how long we can kind of maybe push this to be operational again. Having media backups stored offsite for data recovery, and having that disaster recovery plan. Describing the activities that will occur if there's some kind of disruption in service. And now you might not have known that first one up there existed, that business interruption insurance. That probably kicked in and helped a lot of people earlier in the year. And so that's where we're going to leave off for today. We've gone a little bit over where we'd normally go since we got started a little late. The time's run a little long, but even still, we've run a little long on the clock than we normally would without looking at the time. So I'm going to stop here for today. We've got a lot of other stuff covered in your textbook that you'll be examining. Remember that if you have any questions, please make sure to let me know. But that's all that I have for you today. Thank you for watching. I'll hang out in the chat for just a couple minutes just to see if anybody who's watching with me has any questions. But that's all that I have for you for today. Thanks for watching, and we'll see you next time.